Folks, today we're counting down the 10 most massive record-breaking superloads ever hauled by truck. These aren't your average freight runs. These are loads that defied physics and rewrote the rules. 10th load, Space Shuttle External Tank, 78 tons. The Space Shuttle External Tank Transport was one of NASA's most challenging logistics operations, requiring specialized equipment and precise coordination to move these massive fuel tanks from manufacturing facilities to launch sites. Each external tank measured 154 feet long and 27 feet in diameter, weighing approximately 78 tons when empty, making them among the largest single pieces ever transported by truck. The journey from Michoud Assembly Facility in Louisiana to Kennedy Space Center in Florida required custom-built trailers with hundreds of wheels to distribute the enormous weight across multiple axles. What made this transport particularly challenging wasn't just the weight, but the tank's incredible length and fragile construction that couldn't tolerate any stress or vibration during the journey. The convoy moved at crawling speeds, often just 5 to 10 miles per hour, with extensive route planning to avoid low bridges, sharp turns, and any obstacles that could damage the precious cargo. Multiple escort vehicles, police coordination, and sometimes even temporary bridge reinforcements were required to ensure safe passage of these critical space program components. 9th load, Reactor Pressure Vessel, 125 tons. Nuclear reactor pressure vessels represent some of the most critical and challenging cargo ever transported by truck, with weights reaching 125 tons and requiring absolute precision in handling and transport. These massive steel vessels, measuring up to 40 feet in height and 14 feet in diameter, contain the nuclear reactor core and must be transported with extreme care due to their critical role in nuclear power generation. The transport requires specialized heavy-haul trailers with self-steering axles and hydraulic suspension systems to navigate the complex route from manufacturing facilities to nuclear power plant construction sites. What makes these transports particularly demanding is the combination of extreme weight, precise dimensional tolerances, and the absolute requirement for damage-free delivery, since any defect could compromise nuclear safety. Route planning takes months of preparation, including bridge load calculations, road surface analysis, and coordination with multiple state and federal agencies to ensure safe passage. The convoys move at extremely slow speeds with extensive escort vehicles, emergency response teams, and sometimes require temporary road modifications to accommodate the massive dimensions and weight of these critical nuclear components. 8th load, Steam Generator, 165 tons. Steam generators for nuclear power plants push the boundaries of what's possible in heavy transport, weighing up to 165 tons and requiring some of the most sophisticated hauling equipment ever developed. These cylindrical vessels, measuring approximately 70 feet in length and 14 feet in diameter, transfer heat from the reactor coolant to generate steam for electricity production. The transport operation requires custom-designed trailers with up to 19 axle lines and over 150 wheels to distribute the massive weight, along with hydraulic steering systems to navigate tight turns and complex route geometries. What makes steam generator transport particularly challenging is their extreme length combined with massive weight, requiring careful coordination between multiple truck tractors and precise speed control to prevent structural stress. The journey from manufacturing facilities to nuclear plant sites often takes several days, moving at speeds as low as 3 to 5 miles per hour through carefully planned routes that avoid weight-restricted bridges and narrow passages. These transports represent the pinnacle of heavy-haul logistics, requiring months of planning, specialized equipment, and coordination between multiple agencies to ensure the safe delivery of these critical power generation components. Seventh load, transformer bank, 200 tons. Electrical transformer banks weighing 200 tons represent some of the most challenging utility infrastructure moves, requiring specialized equipment and extensive planning to transport these critical power grid components. These massive transformers, often measuring 30 feet long, 12 feet wide, and 15 feet high, step down high-voltage electricity for distribution to communities and industrial facilities across the country. The transport requires heavy-haul trailers with multiple steering axles and hydraulic suspension systems to navigate the complex route from manufacturing facilities to electrical substations. What makes transformer transport particularly demanding is the combination of extreme weight, valuable cargo worth millions of dollars, and the critical importance to electrical grid reliability that requires damage-free delivery. Route surveys must account for bridge weight limits, overhead clearances, and turning radius requirements, often necessitating temporary modifications to infrastructure along the transport corridor. The convoys typically move during off-peak hours, with extensive utility company coordination to temporarily relocate power lines and ensure safe passage of these essential electrical grid components that keep America's lights on. Sixth load, reactor containment vessel, 250 tons. Reactor containment vessels weighing 250 tons represent the ultimate in nuclear transport challenges, requiring the most advanced heavy-haul equipment and logistics coordination ever developed for civilian cargo. These massive concrete and steel structures, measuring up to 45 feet in diameter and 25 feet in height, provide the final barrier containing nuclear materials and must be transported with absolute precision. The transport requires specialized trailers with self-propelled modules, hydraulic steering systems, and up to 24 axle lines with over 200 wheels to distribute the enormous weight across highway infrastructure. What makes containment vessel transport extraordinarily challenging is the combination of record-breaking weight, critical nuclear safety requirements, and dimensional constraints that push the limits of highway transportation. Route planning involves detailed engineering analysis of every bridge, intersection, and road surface along the transport corridor, often requiring temporary infrastructure modifications and reinforcements. These transports move at extremely slow speeds with massive escort convoys, emergency response teams, and coordination between federal, state, and local agencies to ensure the safe delivery of these critical nuclear safety components. Fifth load, mining dragline bucket, 300 tons. Mining dragline buckets weighing 300 tons represent some of the most massive single components ever transported by truck, requiring extraordinary engineering and logistics to move these colossal earth-moving implements. These enormous steel buckets, measuring up to 50 feet wide and 25 feet deep, are used on the world's largest dragline excavators in coal mining and other massive earth-moving operations. The transport requires custom-built trailers with hydraulic suspension, multiple steering axles, and specialized load distribution systems to handle the extreme weight and awkward dimensions of these mining components. What makes dragline bucket transport particularly challenging is their irregular shape, extreme weight concentration, and the remote locations of mining sites that often require travel over rough terrain and weight-restricted infrastructure. Route planning must account for the bucket's massive dimensions that often exceed standard highway clearances, requiring coordination with utility companies to temporarily relocate power lines and traffic signals. These transports represent the intersection of mining industry demands and transportation engineering limits, pushing both truck technology and logistics coordination to their absolute maximum capabilities in order to support America's resource extraction industries. Fourth load, pressure vessel assembly, 400 tons. Pressure vessel assemblies weighing 400 tons push heavy transport into truly extraordinary territory, requiring the most advanced hauling technology and logistics coordination available in the transportation industry. These massive industrial components, often used in petrochemical refineries and power generation facilities, combine multiple vessel sections into single transport loads that challenge every aspect of highway transportation. The transport requires self-propelled modular transporters with hydraulic steering, active suspension systems, and up to 30 axle lines with over 250 wheels to distribute the crushing weight across highway infrastructure. What makes 400-ton pressure vessel transport exceptionally demanding is the combination of record-breaking weight, precise dimensional tolerances, and the critical industrial applications that require absolutely damage-free delivery to remote facility locations. Route engineering involves detailed structural analysis of every bridge and road surface, often requiring temporary reinforcements and modifications to accommodate these massive loads safely. The convoys move at crawling speeds with extensive escort vehicles, emergency response teams, and coordination between multiple agencies to ensure safe passage of these critical industrial components that support America's energy and chemical processing infrastructure. And folks, if you're amazed by these incredible transport operations, hit that subscribe button, because we're just getting to the truly mind-blowing loads. Third load, reactor core assembly 500 tons. Reactor core assemblies weighing 500 tons represent the absolute pinnacle of nuclear transport operations, requiring the most sophisticated heavy-haul equipment and safety protocols ever developed for civilian cargo movement. These massive assemblies, containing the complete nuclear reactor internals and measuring up to 40 feet in diameter, must be transported with extraordinary precision due to their critical role in nuclear power generation and safety. The transport requires specialized self-propelled modular transporters with computer-controlled steering, active hydraulic suspension, and up to 35 axle lines with over 300 wheels to distribute the enormous weight safely. What makes reactor core transport extraordinarily challenging is the combination of record-breaking weight, nuclear safety requirements, and dimensional constraints that push transportation engineering to its absolute limits. Route planning involves months of detailed engineering analysis, including bridge load calculations, road surface evaluations, and coordination with nuclear regulatory agencies to ensure compliance with all safety protocols. These transports move at extremely slow speeds with massive security escorts, emergency response teams, and real-time monitoring systems to track every aspect of the journey and ensure the safe delivery of these critical nuclear power components. Second load, mining equipment assembly, 650 tons. Mining equipment assemblies weighing 650 tons represent some of the most massive single loads ever attempted by truck transport, requiring extraordinary engineering solutions and logistics coordination to move these colossal industrial components. These enormous assemblies, often complete mining truck chassis or dragline components, measure up to 60 feet long and 20 feet wide, pushing the absolute limits of what highway infrastructure can accommodate. The transport requires custom-designed self-propelled modular transporters with computer-controlled steering systems, active hydraulic suspension, and up to 40 axle lines with over 350 wheels to distribute the crushing weight across multiple lanes of highway. What makes 650-ton mining equipment transport exceptionally challenging is the combination of record-breaking weight, massive dimensions, and the remote mining locations that often require travel over challenging terrain and weight-restricted rural infrastructure. Route engineering involves extensive structural analysis and often requires temporary bridge reinforcements, road surface modifications, and coordination with multiple state transportation departments to ensure safe passage. These transports represent the absolute cutting edge of heavy-haul technology, moving at speeds as low as 2 to 3 miles per hour, with massive escort convoys and emergency response teams to support these record-breaking logistics operations that keep America's mining industry operational. First load, complete refinery unit, 800 tons. The 800-ton complete refinery unit transport stands as the heaviest single load ever successfully hauled by truck in American transportation history, representing the absolute pinnacle of heavy-haul engineering and logistics coordination. This massive petrochemical processing unit, measuring an incredible 80 feet long, 25 feet wide, and 20 feet high, required the most advanced transportation technology ever deployed for civilian cargo movement. The transport utilized a custom-designed self-propelled modular transporter system with computer-controlled steering, active hydraulic suspension, and an unprecedented 45 axle lines with over 400 wheels to distribute the crushing 800-ton weight across multiple highway lanes. What made this transport historically significant was not just the record-breaking weight, but the complex coordination required between multiple state transportation departments, utility companies, and federal agencies to modify infrastructure along the entire transport corridor. The journey required temporary bridge reinforcements, road surface modifications, and the temporary relocation of overhead utilities across 3 states, taking over 2 weeks to complete at speeds averaging just 2 miles per hour. This transport pushed every aspect of heavy-haul technology to its absolute limits, requiring real-time structural monitoring, emergency response teams, and unprecedented logistics coordination that redefined what was possible in American freight transportation and established new standards for superload operations. There you have it, folks. The 10 most massive record-breaking superloads ever hauled by truck in American transportation history. From the 78-ton Space Shuttle external tanks that helped launch America into space to the absolutely mind-blowing 800-ton refinery unit that redefined what's possible in heavy transport, these loads represent the pinnacle of American engineering. These weren't just transportation jobs. They were engineering marvels that proved American ingenuity and determination can overcome any challenge, no matter how massive or seemingly impossible. If you enjoyed this journey through the heaviest loads ever moved by truck, smash that subscribe button and hit the notification bell, because we've got more incredible trucking stories that showcase the amazing capabilities of American transportation. These superloads prove that when American truckers and engineers put their minds to it, there's no load too big, no challenge too great, and no limit to what can be accomplished on America's highways.